This presentation is about trigonometric graphs. Lesson objectives. First of all, to be able to plot a trigonometric graph, and second of all, to be able to sketch a trigonometric graph. Now, first example is to dealing with plotting a trigonometric graph. So in this case, we need to draw the graph of y equals 2 sine of 3x. Now, to be able to plot a graph of any type, we basically stick x values. X is here in this particular function, and then we calculate the function to be able to find our y value. So the best way to do this in the form of a table and then to calculate the function for each of those values. Now my general recommendation is to do it for all the x values that are on the coordinate axes and work out the corresponding y. So in this case I've created a table from 0 to 360 going up in 30s. And for each of these, we stick the x value into the function. So when x equals 0, we get y equals 0. X equals 30, we get y equals 2. X equals 60, y equals 0. X equals 90, we get minus 2. X equals 120, we get y equals 0. X equals 150, we get y equals 2. And in fact, it will carry on as a pattern. So we'll get 0, minus 2, 0, 2, 0, minus 2, 0. Now, we have to then plot all those points on the graph. So each in turn across the x value up or down to the y value. So plotting all those points, we end up with this. 0, 0, 32, 60, 0, 90, minus 2, and so on. Then, once we're all at the points, we have to plot a nice smooth curve for all of those. Now, because this is a sine graph, and the same would go for a cos graph, we need to draw a nice smooth sine wave for each of these points. So it should be, instead of joining them up with straight lines, they should be fairly curved to represent the sine wave. So that would be the graph of y equals 2 sine 3x by plotting. Now, to be able to sketch graphs, basically what we do is we start with the basic graphs and then we transform them to the graph that we want. So this is the graph of y equals sine of x from minus 180 to 360. So we get the typical sine wave. It's got a period of 360 degrees. That means that we see one version of curve from 0 to 360 degrees, and then the next 360 degrees will be the exact same shape. Goes from minus 1 to 1 on the y-axis. This is a graph of y equals cos x. Same region from minus 180 to 360. Like the sine graph, it also has a period of 360 degrees. Starts at 0, 1, and by 360 it's back up at 1 on the y-axis. Y-axis goes from minus 1 to 1, and you have that nice smooth sine wave. And then the final graph is y equals tan x. Now tan x is very different from y equals sine x and y equals cos x. It only has a period of 180 degrees. As you can see on this graph, from minus 90 to 90, we get a full version of the curve, and then we get the same one again from minus 90 to 270. Now the tan curve has what we call asymptotes at minus 90, 90 and 270, and further on as the cycle repeats. Now, asymptotes at minus 90 there, 90 here, so we haven't got it precisely on the line, and 270 here, the better one. Asymptotes are lines on the graph paper that the curve doesn't cross, so the curves will get closer and closer to these asymptotes, but never actually touch them or pass through them. Now we can do stretches to these basic trig graphs to form sketch graphs of the form y equals a sine bx, y equals a cos bx, and y equals a tan bx. The a is a stretch factor a in the y direction. This means that the curve will no longer go between minus 1 and 1 on the y-axis. This is of course for sine and cosine curves, which we most often do the stretches for. It won't actually make a visual difference to the y-axis in a sketch. because the stretch will retain its same shape and go off to infinity and minus infinity on the y-axis. But for a sine and cosine curve, instead of going between -1 and 1, it'll now go between -a and a. Whereas the b is a stretch factor 1 over b in the x direction. And this means that the number of copies we see in the wave will be multiplied by b. So if we normally get one copy between 0 and 360 of the sine x curve. If we were to replace x with 2x, we'd see 2 copies of the sine wave curve between 0 and 360. So, example A, if we were to sketch y equals 3 sine x from 0 to 360, we'd start off by sketching y equals sine x from 0 to 360. So in this case we have it from going from -1 to 1 on the y-axis. It crosses the x-axis 180 and 360. So this is the standard curve that's in A level you would be expected to remember. Now if we want to sketch the curve of y equals 3 sine of x, well the 3 in front of it, that's where the capital A was. So now the curve will go between -3 and 3. But it'll still cross the x-axis in basically the same places. So as far as the sketch goes, it looks pretty much the same, but you've changed those values on the y to be -3 and 3. Example B, y equals cos of 2x. Now we start by sketching cos x, let's say the standard curve that you always start with in such sketches. So it goes from -1 to 1 on the y-axis, crosses at 90 and 270, and we see one copy of the curve between 0 and 360. Now the 2 in y equals cos 2x is where the b would be. So this means we'll see 2 copies of the cos x curve between 0 and 360 degrees. So this is what this means. So you see one copy from 0 to 180, so it's squashed in towards the y-axis, and then we see a second copy from 180 to 360. And that would be a sufficient sketch of y equals cos of 2x. Now you may be asked to do a combination of those 2 sketches. Now y equals 5 cos 2x, we've already got y equals cos 2x on the last graph. So we've got cos 2x, 2 copies between 0 and 360. The 5 is where the a would be, so now this curve, instead of going between -1 and 1 on the y-axis, will now go between -5 and 5. But it'll still look fundamentally the same. So we can do that transformation in 2 steps. First of all, sketching the graph of y equals cos 2x from the graph of y equals cos x, and then the graph of y equals 5 cos 2x from the graph of cos 2x. And that's it.